Hello and welcome to helpyourmath.com. In this video, we are going to go over question 20 of the Math 206.5 Final Exam Review. We're given two functions, f and g, and we want to find their sum, their difference, and their quotient, and then with the quotient, the domain. For both f and g, the domains would be all real numbers because they're both polynomial functions. But when we get to division, there are some issues that we have there. What we're looking at in A is, this is just fancy speak, so saying f plus g of x is really just asking us to figure out what is f of x plus g of x. It's just the sum function, adding these two together. How do we add these two functions together? Well, we're going to take what we know they're equal to, and then we'll look for like terms. So f of x is the same thing as x squared. I'm just going to put it in parentheses, not because I have to, just to show this is f of x. And we're going to add to it g of x, which is 2x squared minus 8x. The parentheses aren't really doing anything. I just added them for emphasis so we could see f of x and g of x more clearly. From here, we're going to look for like terms. We have x squared plus 2x squared. So x squared plus 2x squared would be 3x squared. Next, we have negative 3x and minus 8x. And if we were to combine those, we would get minus 11x. And we'll notice we have just one single constant term, minus 4. So we're just going to bring over minus 4. And this would be our sum function, 3x squared minus 11x minus 4. Part B is looking for the difference function. So this would be the f minus g of x is really just asking us to find what is f of x minus g of x. And notice when it's subtraction that the order does matter. So it does matter that f is first and g is second. When I write this, I will put them in parentheses again, only this time I absolutely need the parentheses for that g of x. Because that whole function gets subtracted. So we have x squared minus 3x minus 4, that's just f of x, minus g of x, 2x squared minus 8x. What I like to do is distribute the subtraction sign so I don't lose it. There would be a minus here, and then this minus would turn into a plus, and then that becomes a plus, just so that way I don't have to keep looking to the subtractor, even forget about it. That would be terrible. Once I've done that, I can start looking for my like terms. I have x squared, and negative 2x squared would be negative x squared, minus 3x and plus 8x, so minus and plus we would subtract, that gives us 5, and we would keep the sign of the 8x, so we end up with positive 5x, and then we have that minus 4 again. So our difference function is negative x squared plus 5x minus 4. Last up, we have our quotient function. So the quotient function is just going to look at f of x over g of x. This would be x squared minus 3x minus 4 divided by 2x squared minus 8x. And then we want, first of all, it should say and simplify. So we'll go ahead and simplify, and we'll also find the domain. To do both simplifying and finding the domain, I need to factor. So we're going to factor the numerator. The numerator has a target product of negative 4, that's a times c. A is 1, c is negative 4, and a target sum of negative 3. We can use the shortcut since the leading coefficient is 1, so once we know the combination that multiplies to negative 4 and adds up to negative 3, we can plug those right in. The winning combination is, say it with me, negative 4 and positive 1. So this will factor into x minus 4 times x plus 1. In the denominator, we have a GCF, 2x squared and 8x have a GCF of 2x. Leaving behind, if I divide the first term by 2x, I'm left with x. If I divide the second term by 2x, I get minus 4. And now we're going to pause because this is where we're going to determine the domain. So the domain has restrictions because now that we have this fraction, it is possible that we could have a 0 in the denominator, which would not produce a real number output. So those are not allowed. Those get pulled out of the domain. So we're going to say that 2x times x minus 4 cannot equal 0. And then we use what's called the zero product property to determine, okay, what are the exact values that would give us that 0, cannot equal 0. So we would say, okay, well, here's 1. We're going to say 2x cannot equal 0, which means x cannot equal 0. Or x minus 4 cannot equal 0, so x cannot equal positive 4. So the domain here would include all real numbers except for 0 and 4. Because remember what a domain is, it's the numbers that we can plug in that give us a real number output, assuming there's no other restrictions given to us for the function. To write this in interval notation, I'm going to say it's negative infinity to 0, and then from 0 to 4, and from 4 to infinity. So that's the domain. But now the other thing I want to do is I want to simplify this function. Both the numerator and denominator have a factor of x minus 4. So this quotient function will be x plus 1 divided by 2x. It's really important that when you do the domain, you use the unsimplified, because now it looks like the only restriction is 0, but based on the original function, we also can't plug in 4. So this has been the sum function, difference function, and quotient function when we're given two functions. Thank you for stopping by.